You've rattled it off 100 times without thinking twice, at a doctor's office, on a donor card, filling out some form in a waiting room. O positive. It comes out automatically, like reciting your birthday, and nobody pauses on it. Nobody wonders what's actually sitting behind those two characters. Turns out something is. Locked inside that combination is a record your ancestors assembled and sealed shut long before you were born. One scientists have only just figured out how to crack open. If O positive is the blood in your veins, everything from here forward was written for you specifically. Picture a lab in Vienna, 1901. Karl Landsteiner is mixing blood samples on glass slides, and something is wrong. Some combinations sit still, others seize up instantly, clumping into something that looks less like chemistry and more like a warning. For decades, patients had been dying mid-transfusion, and no one could say why blood that saved one person killed the next. Landsteiner had just found the answer. He named 3 groups, A, B, and O. A fourth followed soon after. For the first time in medical history, a doctor could look at your blood before a transfusion and know, in advance, whether it would save you or kill you. In 1930, it won him the Nobel Prize. He'd cracked the lock. He never knew there was a key still buried inside it, one that wouldn't surface for almost 100 more years. Here's that mechanism, stripped down. Every red blood cell you own wears a costume, built in 2 steps. Step 1. A gene called FUT1 builds the base layer, called the H antigen, on every cell you have. Step 2. The ABO gene, on chromosome 9, decides whether to stitch anything extra on top of that base. In type A and B blood, it stitches something on. In your blood, if you're O positive, that second gene has been switched off, so the base stays bare, nothing added, nothing extra. One more gene, on a different chromosome, decides if you're positive or negative. 3 genes, quietly running in the background of every cell you have, and together they built the blood type shared by close to 3 billion people alive right now. For decades, scientists assumed type A came first, and since it showed up on every continent, that felt like ancestry, like proof of a single origin point. Then in 2012, geneticist Laure Seguerel and her team at the University of Chicago sequenced the gene at full resolution and broke that theory apart. Type O has arisen independently, more than once, through different mutations, landing on the same gene in different populations. Seguerel's team checked gorillas, orangutans, macaques, and found the same A and B markers in species that split from us over 10 million years ago. In 2021, ancient DNA confirmed it from the other side. A Neanderthal carried a rare AB-type variant, and a Denisovan carried O of her own. Your blood type isn't a human invention. It's a primate inheritance, quite possibly one of the oldest traits still actively running in your entire family tree. So why does O dominate entire regions of the planet? Among some indigenous populations of the Americas, O approaches near total frequency. The likely reason sits at the edge of the last ice age, roughly 15,000 to 20,000 years ago, when small founding families crossed Beringia, the land bridge from Siberia to Alaska, through cold most of us will never come close to feeling, carrying only the genetic variants they happen to have on them. Pour a handful of marbles from a jar of 100 colors into an empty jar, and the new jar isn't a fair sample. It's just whatever was in your hand, magnified across thousands of years and millions of descendants. Now here's what that inheritance actually does for you. If you're O positive, you are measurably less likely to develop the severe organ-failing form of malaria, one of the deadliest diseases in human history. Picture what the parasite is trying to do inside you. Weld your infected blood cells into small clumps that jam your narrowest vessels and choke off blood flow to your organs. In O-positive blood, the surface the parasite needs to grab onto to build those clumps simply isn't there. The clumps can't form. Your vessels stay open. And the protection doesn't stop with malaria. In a Harvard-led study, tracking over 100,000 people, O carriers came out with the lowest pancreatic cancer risk of any blood type, while type B carriers ran a 72% higher risk, and type AB ran 51% higher. Your heart benefits too. O-positive blood runs naturally lower levels of a clotting protein called von Willebrand factor, and in a separate Harvard study of nearly 90,000 people, non-O blood types carried up to 23% higher odds of coronary heart disease as a direct result. 3 separate battles, 3 separate wins, all coded into the same 2 characters on your chart. That same lower clotting protein does have a flip side. You likely bleed a little more freely after an injury or surgery, the trade-off for the arteries it's keeping clear. You're also more vulnerable to peptic ulcers, linked to a bacterium called Helicobacter pylori, which grips onto O-positive cells more easily than it grips A or B. And in 1991, when cholera tore through Trujillo, Peru, a region descended from that same Beringia crossing, O-positive carriers there were nearly 8 times more likely to be hospitalized with severe disease. Nothing about your blood is simply good or bad. It's a negotiation, and you're still collecting and paying on it right now. In 2020, that same negotiation showed up again. Researchers found O-positive people faced a lower risk of COVID infection and a milder course if they caught it. The same ancient code still working a shift in hospitals 4 years ago. Then, in 1952, a hematologist named Dr. Y.M. Bende was working in a Bombay hospital when he found something that broke the entire system. A patient needed a transfusion. Every test marked them as type O, the blood type doctors reach for first, compatible with roughly 4 out of 5 people on Earth. They were given type O blood. Their body attacked it immediately, violently, like poison, and it made no sense. O is supposed to be safe for almost any Rh-positive recipient. Bende went looking for what the test had missed, and what he found wasn't a rarer version of O. It was something underneath O entirely. Standard blood tests only check for the A and B markers. They were never built to check for the H antigen those markers sit on. This patient had none of it, and no test in the world was designed to notice. They named it the Bombay phenotype, also called O, or the HH blood group, run by an entirely separate set of genes from your A, B, or O. Carriers can only safely receive blood from someone with the exact same rare condition. Roughly 1 in 10,000 in parts of India, closer to 1 in a million in Europe, hidden for decades because the system was never built to look for it. If you think that's rare, it isn't the rarest. Right now, roughly 43 people on Earth carry what's called Rh null, golden blood, missing every Rh antigen a body can carry. About 1 in 6 million, safe for almost anyone in that system who needs it, and almost impossible to replace if one of those 43 people ever needs blood themselves. The founder effect was already written into you. The malaria trade was already written into you. The Bombay phenotype was already written into you. All of it was there before anyone thought to look. If you're O-positive, those 2 characters on your chart aren't a label. They're what's left of an ancestor who survived something that should have killed them, passed down hand to hand until it reached you, still standing guard in your blood, still doing its job, whether you ever asked it to or not.